extension. Similarly, we can write dimensional formula of any physical quantity. Now let us go to the next one. What are the uses of dimensions? The first one is dimensions are used to convert the unit of a physical quantity from one system to another system. To convert a unit of physical quantity from one system to another system, we use this formula. It's very clear. The dimensions are used to convert unit of a physical quantity from one system to another system. And the second one is, they are also used to check the correctness of an equation. They are used to derive certain relationship among certain physical quantities. They are also used to derive dimensions of physical quantities. Let us try to understand these uses of dimensions one by one. Okay, here is an example. How do you convert 7 joule into earth? As all of us have studied in the beginning of units and measurements that there are systems of units. The CGA system, the FA system, the MK system, and finally the SI system. In CGA system, the length is in centimeter, the mass is in grams, and the time is in seconds. In MK system, the length is in meter, the mass is in kg, and the time is in seconds. In FA system, the length is in foot, the mass is in pound, and the time is in seconds. In SI system, we have 7 fundamental units. That is, length is measured in meter, mass is measured in kg, time is measured in second, electric current is measured in ampere, luminous intensity is measured in candela, amount of substance is measured in mole, temperature is measured in Kelvin. These are the SI units of 7 fundamental quantities. Apart from these, there are 2 more fundamental quantities. The plane angles. The plane angles are measured in degrees. The plane angles are measured in radian in SI system. And the solid angle is measured in steradian in SI system. Now let us go to this application of dimensions. That is the first one. Converting one unit of a physical quantity into another unit. Now, in SI system, the unit of energy is joule, whereas in CGA system, the unit of energy is erg. How do you convert joule into erg? Look here, we have the dimensional formula of work, and we have the SI unit and the CGS unit, and we have a formula to convert one unit into another unit. Let us write the formula first. What is the formula? N2 is equal to N1 into M1 by M2 raised to A into L1 by L2 raised to b into T1 by T2 raised to c. Okay. What are N2 and N1? N2 and N1 are constants, are numbers, are numericals, And what is this M1? M1 is the mass in SI system. As all of us know that the mass is measured in kg. In SI system, the length is measured in meter. In SI system, the time is measured in seconds. Whereas in CG system, the mass is measured in gram, the length is measured in centimeter, the time is measured in second. Now let us understand. N2 is equal to N1. What is N1? We need to convert 7 joules of energy into Earth. This 7 is the number that is given. It may be 7, it may be 8, it may be 1, or it may be anything. So 7 into M1. M1 is 1 kg. 1 kg. M2 is 1 gram. How do you write this 1 kg? You look here, the dimensional formula of work. The work depends on mass raised to 1, length raised to 2, time raised to minus 2. Therefore, m raised to 1, I have written here the value of A is 1. How do you write L1? L1 here I will write 1 meter, and L2 I will write 1 centimeter, and the power of B here is 2. Similarly, the time in both the system it is second only, and the power C is minus 2. So now I am going to write this as, then 1 kg is known as 1000 grams. 1000 grams. 1000 gram divided by 1 gram raised to 1. 1 meter is 100 centimeter divided by 1 centimeter raised to 2. And this is 1 second, 1 second. There is no need of conversion. Then this 7 gram cancels. We get 10 raised to 3. 10 raised to 3. 3 into 1 will be 3. Here centimeter get cancelled. We get 100 by 1. 100 by 1 is nothing but 10 raised to 2. The 10 raised to 2 whole raised to 2. Yes, just like here 10 raised to 3 whole raised to 1. Here second cancels. We get 1. 1 by 1 is 1 raised to minus 2. Now I will write this as 7 into 10 raised to 3 into 10 raised to 4. 1 raised to minus 2. 1 raised to any number is 1 only. Whether it is a negative integer or positive integer, 1 raised to any number is 1. So, we get 7 into 10 raised to 3 plus 4, 10 raised to 7 arc. So, we have converted 7 joules into earth. 7 joules equal to 7 into 10 raised to 7 arcs. This is how we convert a unit of a physical quantity from one system to another system. Now let us go to the other use of dimensions. Like this, you can convert like this, you can convert 1 Newton is equal to how many dyne? Newton is the SI unit of force. Dyne is the unit of force in CGS system. You can convert. Fine. So use that method to convert 1 Newton equal to how many dynes. This is a homework for you. Now let us go to second part of dimensions. That is to check the correctness of a given equation. Here is given that the final position of the body minus the initial position of the body, what we call it a change in position of the body, is equal to the initial velocity vi into time taken minus half times the acceleration and to t square. The change in position, the displacement, change in position is equal to the initial velocity into time plus half of a into t square. Wait, how do we check this equation is correct or not? Dimensionally we have to check it. To check the equation, whether the equation is correct or not, the idea behind this is the left hand side dimensions must be equal to the dimensions of the right hand side terms. Okay, x2, the position, change in position. This is also the change in position. Sorry, x2 is the final position. x1 is the initial position. This is change in position. This we call it is the displacement. The dimensional formula of displacement is L raised to 1. The dimensional formula of velocity, that is meter per second, L raised to 1 and t raised to minus 1. The dimensional formula of time is t raised to 1. The number has no dimensions. The dimensional formula of acceleration is L raised to 1, t raised to minus 2. And the dimensional formula of time square is t raised to 2. Now, this is L raised to 1. Here what happens? L raised to 1, t raised to minus 1 plus 1. So this becomes t raised to 0 plus here it is L raised to 1, t raised to minus 2 plus 2 will become t raised to 0. Now here we write that L raised to 1 equal to 2 times L raised to 1 t raised to 0. Number has no dimensions. This number has no dimensions. So we can write that L raised to 1 is equal to L raised to 1. This has no dimensions. And t raised to 0. Here also you can write t raised to 0. So what we got is L raised to 1 is equal to L raised to 1. That means this equation is dimensionally correct. Likewise, you can take any equation. Say for example, potential energy is equal to kinetic energy, or kinetic energy is equal to potential energy. At the highest point, the object will have potential energy. At the highest point, when the object is at rest, when it just before reaching the ground, all that potential energy is converted into kinetic energy. So at the highest point, potential energy, at the nearest point, kinetic energy. According to conservation of energy, at every point, the total energy remains constant. So let us say that mgh, the potential energy, equal to the kinetic energy. How to prove this equation is dimensionally correct? If a dimensional formula of mass is m raised to 1, acceleration due to gravity, the dimensional formula of acceleration, L raised to 1, T raised to minus 2, the dimensional formula of height, L raised to 1, half has no dimensions, the dimensional formula of mass, m raised to 1, the dimensional formula of velocity, L raised to 1, T raised to minus 1. Since square is there, I will write here square. Square is there, square. This is the dimensional formula of velocity, meter per second. Then how do you write this one? We write that m raised to 1. Here 1 plus 1 will become 2 and t raised to minus 2. And this is equal to m raised to 1. L raised to 1, 1 into 2, L raised to 2, minus 1 into 2, minus 2. We understood that the left hand side and the right hand side dimensional formulae are same. Therefore, this equation is correct. Likewise, you take any equation and check that equation whether it is dimensionally correct or not. Say for example, you take this, the dragging force given by Stokes, F is equal to 6 pi eta AB. The dragging force is equal. 6 is a number, no dimension. Pi is a number, no dimension. Eta, the coefficient of viscosity, the radius of the drop, and V is the velocity of the falling sphere. Stokes says that whenever a sphere is falling in the fluid, there is a dragging force, there is an opposing force. That force is equal to 6 pi eta. What is this eta? Eta is the coefficient of viscosity of the fluid through which the sphere is falling, and A is the radius of the sphere. A is the radius of the sphere, and V is the terminal velocity, the velocity of the sphere which is falling in the fluid. The terminal velocity is the constant velocity. Okay, substitute the dimensional formula of force, coefficient of viscosity, radius, velocity, and find out that whether this equation is dimensionally correct or not. Fine. So let us go to the next one. The next one is dimensions are used to derive a relation which contains several physical quantities. Here is an example. The frequency of vibration of a stretched string depends on length, mass, per unit length, tension. Derive a relation between them. At the end, it is proved that the frequency is equal to the constant divided by length under the root of the tension and the mass. Let us prove this formula. How do we start? First of all, as per the task, as per the problem, the frequency depends on length, mass per unit length, and tension. So I will write that this frequency depends on three factors. One is the length raised to A, don't know how many times, and it depends on mass per unit length, that is mu or m, mass per unit length, mu raised to B, and the third one is tension. How do we write tension? Okay, let us take tension as a small t raised to C. Length raised to A, then this mu raised to B means mass per unit length into tension raised to C. So it depends on frequency is equal to this has some constant. I will write this constant as K. Then I will write that L raised to E. Then m raised to B, mu raised to B, and t raised to C. Fine. Now let us write the dimensional formula of both the side. The dimensional formula of frequency is t raised to minus 1. Frequency, how do we write? We write that the reciprocal of time period is called frequency. And this is a constant which has no dimensions. The dimensional formula of length is L raised to A. The dimensional formula of mass per unit length. How do we write? Mass per unit length raised to B. And this is the tension. Tension is nothing but force. How do we write the dimensional formula of tension? Tension is nothing but force. Force is nothing but mass into acceleration. Mass into acceleration. Now here